Hello, everybody. In today's video, I'm gonna show you a little bit, let's say, more complex task, and we will basically sketch the graph of the function which is defined or given by the equation y equals absolute value of x plus 1 take away absolute value of x plus 5. Basically, if you watched the previous video, you basically should be able to do it by your own, but I want to show you again how to do the things, and let's say why this task is a little bit more complex than the previous one, and I will try to explain a couple of connections or knowledge we have from the previous lessons, why the things work like this and why are they behaving like this, and maybe to show you also some tricky things about this procedure. So basically, and why is this method quite useful? Because if you want to sketch the graph of this function, you are not able, and it's not easy to sketch the graph by using any kind of transformation, because this is like a composite function. And basically what it says, you can have a look on this equation like on let's say sketching two graphs, and it consists of two functions. The first one is defined by absolute value of x plus 1, and the second one is defined like by absolute value of x plus 2. So basically what it would mean, we already know by using the transformation that the first function will look like this, more or less, and the second function, as it is shifted 5 units to the left, will look, let me extend this line a little bit, will look something like this. And basically, okay, so this is like x plus 5 and this function is x plus 1, and to sketch the graph you must now take all the values. For example, here is the value of the first function, and here is the value of the first function, this one, and here is the value of the second function. And if you do subtract these values, you will get like the final point here. Then imagine that you have to do it, for example, for this point. What will happen? You take the value of this function, take away of the value of this function. So basically this is the value of the first, and this is as well the value of the second. So if you would subtract them, then the graph of the composite function should go through this point. But what is happening on the left side from -5, for example, here, if I would extend, and here, can you imagine that you subtract this value, because this the length of this line segment is the value of my first function, and this line segment, or the length of this line segment, is the value of my second function. I have to subtract, which is now this part of the line segment. Let me do it a little bit in color, which is this one. So basically you have to take this line, put it into the x-axis and sketch the value of this function. And if you want to do it, you have to sketch quite a lot of points to find out how the function will really behave for all the real numbers. Though it is not a very hard task, but it's quite complex and hard to do. And especially if you would imagine that this is not just the equation is not just having two absolute values, but maybe more, 3, 4, and so on, then the task is becoming really more and more difficult and not easy to solve. That's why we will use the method that was shown in the previous video, where I was sketching really like very simple linear absolute value function. So as we already know, the first step is to find the 0 point I said, but I meant, and I'm really like stressing this information, we will now be looking for 2 0 points because we have 2 absolute values in our equation. So the first 0 point can be found if we will solve the equation x plus 1 equals 0. Where is x plus 1 coming from? This is the expression in the first absolute value. Okay, so x plus 1 is equal to 0 if and only if x is equal to -1. So this is my first 0 point. For the first expression, the second 0 point can be found from the expression from the second absolute value, which is this one. Okay, so basically you look for the solution of this equation, x plus 5 equals to 0, and this is if and only if x is equal to -5. So I have my 0 points. Basically the second thing was that these 2 0 points will split my number line into 3 parts now, because here is my -5, here is my -1. Okay, into 3 parts basically means there will be like 3 intervals, and the third point, if you want to solve or sketch the graph, is to sketch the table. And we will be looking now, this table will have like 3 columns. In the first column will be the interval from -infinity to -5. Let me do it like a little bit more properly. The second interval is -5 to -1, and the last one is from -1 to the infinity. Now I sketched the table a little bit more longer because there will be like 2 rows instead of 1 row, as it was in the previous example. And in the first row we'll be looking how the expression in the first absolute value behaves, or how can be algebraically expressed, and in the second row we will have absolute value of x plus 5. Okay, now the procedure is same like it was before. You take any number from the first interval. So in this case we take -10, and we find what will be the value in absolute value. So -10 plus 1 is -9, so this is negative number, so my expression will become -x minus 1. And I will do the same for the next interval. I choose number -4, so -4 plus 1 is again negative number, so my expression will be -x minus 1. And the last interval is from -1 to the infinity, which means the clever idea, or the best idea, is to take 0. So 0 plus 1 is 1, which is positive number, so my expression must behave like this. Okay, in this situation, let me explain you how can you like a little bit easier find this, or quicker, or to understand why this is happening and why this is happening like this. Basically we are looking for the function graph which is defined by the equation y equals x plus 1. We already know that this graph will look like this, and it will pass through the point 0, 1, okay, which is here, and it will pass through the point -1 and 0. We already know why. So here is my like 0 point, okay, and I'm looking for the information where this function is under the x-axis, and it is happening for all the numbers which are on the left from -1. So basically from here to the left my function if I want to evaluate the absolute value, must be the opposite expression of the expression which is in the absolute value. Okay, and the same thing applies for -5 and the second function. As okay, let me do it this way. As here is -5, and my function is defined by the equation y equals x plus 5, which we already know will go like this, and it means for all the x's on the left from -5 are under the x-axis, which means they are negative, okay, because this part of the graph, okay, let me do it in color, this part of the graph is under the x-axis, okay, and the rest of the graph then, which is this part of the graph, is above the x-axis, which means there are positive numbers. So if you realize this and have this in mind when evaluating your expression in the absolute values, okay, you can do it a little bit quicker, you can do it a little bit faster, and the thing I said during the lesson, maybe some of you when you'll train such a thing quite a lot or so many times, so that you will become like lazy guy, you will not need anymore the point number 2, because you will realize after finding the 0 points that they split or divide the number line into 3 parts, and these are my like ending points in the interval or ending numbers. So let's go back to our task. We want to find the expression, how to evaluate the absolute value of x plus 5. So we again take a negative number like -10. -10 plus 5 is for sure negative number. So my expression is -x minus 5. And as we already know, because I was sketching the graph, all the values on the right side from -5 will be positive, because they are represented by this part of the line or of the graph of the function, which means that in the rest, in these two cells, I can very easily write x plus 5 and x plus 5. Okay, now we go to the fourth point. Let me do it here. So basically we will have now like 3 intervals, so 3 conditions, or we can say 3 domains or 3 functions, and the first one is defined for x from the interval from the negative infinity to -5 closed, though we already know it doesn't matter, but my function then will be defined by the equation. And now, as I'm working on this interval, I have to take only this part of my table, basically only these 2 expressions. Okay, so instead of writing absolute value of x plus 1, I already know that this on that interval behaves like this. So I'll replace it with the expression minus x minus 1 minus. You still keep this sign, okay? You don't take care, or you didn't take care, or you cannot avoid. You just simply write this sign here, and then you choose the expression from this cell, okay, because you are looking for the expression on this interval for this absolute value, which is this expression. So basically you just write into your equation bracket, because here is negative sign, negative x or minus x minus 5, which you simplify, and it will become minus x minus 1 plus x plus 5. Okay, so my equation is y equals 4. This is the first equation. Don't worry, you will see later on that this is correct. The next interval we will be working on is interval from -5 to